Let's have a look at question 4 on the November 2012 P2 higher exam paper. This question is about static electricity, and we've got a thundercloud passing over the top of a metal tower. And at some point, lightning is going to jump from one to the other. So it asks us, or tells us, sorry, when the charge cloud is over the metal tower, a charge builds up on the top of the metal tower as the cloud passes over, and during the lightning flash, a flash of lightning travels between the cloud and tower. We're now asked to put a tick in the correct box here to describe the charge on the top of the cloud and the top of the tower, and the rule of thumb here is opposites. So if the bottom of the cloud is negative, then the top of the cloud is going to be positive, so it's either C or D. And then if the bottom of the cloud here is negative, that's going to repel electrons away from the top of the tower, making the top of the tower positive. So it's positive for both, which makes the answer C. Okay, we've now got four statements. Opposite charges attract each other, like charges repel, ice particles gain electrons, and ice particles lose protons. We've got to choose the best reason for some of these things happening. So let's have a look here. In the cloud, the bottom of the cloud becomes negatively charged, and that's because ice particles gain electrons. And if something gains electrons, because electrons are negatively charged, it makes them negative overall. It then says, when the charged cloud is over the metal tower, the top of the cloud becomes charged. Sorry, top of the tower becomes charged. But as I said in the previous part, the negatively charged bottom of the cloud is going to repel the electrons away from the top of the tower, and so that's going to be reason 2, like charges repel each other. And then it says, explain what happens to the charge on the metal tower as a result of the lightning flash. Well, the charge on the metal tower becomes neutralized by electrons flowing from the cloud to the tower. So let's just see what the mark scheme says there. Here we are then. So the charge is neutralized by the transfer or flow of electrons. Nice and straightforward. Okay, it then says during the lightning flash a total charge of 52 C flows, and that's 52 coulombs. The average current is 2,600 amps. Calculate the duration of the flash in seconds. We've got 3 marks for this, which is quite a lot. Well, we're asked for a time here. The duration obviously is the time. We've got some charge and we've got some current. So let's see if there's an equation that links those 3. So let's go right back to the start of the exam paper. So where are we? Here we are then, the first one. Charge equals current times time. Well, if we look at this equation, charge equals current times time, we'll take that back down with us mentally to the question. Here we are. Oops, here we are. Okay, so charge equals current times time. If you imagine charge equals current times time, if I want to get time on its own, I need to remove the charge from the right hand side, divide both sides by the charge, which gives me current, say that the wrong way around. If I've got charge equals current times time, I need to divide both sides by the current to give charge over current equals time. And so in this case, I'm going to do 52C divided by 2600A, and that's going to give me hopefully the correct answer. So let's check the mark scheme for that one. So here we are then. So 52 equals 2600 multiplied by the time. And that gives us 1 mark. If I rearrange the equation to give time equals 52 over 2600, I get the 3rd mark. And then finally, putting those numbers into a calculator and getting 0.02 seconds gives me the final answer, the final mark. And it's worth noting at this point, if you've got a calculator that as standard gives an answer as a fraction, remember to press the S to D button to make sure that you write down your number as a decimal. Okay. It now says, when fuel tanks on an aircraft are being filled, the aircraft fuel pipes and tanker are connected by a metal wire to the ground. Explain why this greatly reduces the chance of a spark. Well, it's pretty simple. The fuel flowing along the pipes, as the fuel transfer takes place, causes static through friction, and if the tank and the aircraft are not at the same potential, then a spark can jump from one to the other and ignite the fuel vapour. So let's see how the exam paper puts that into words. So, okay, they've got it pretty straightforward here. Charges flow through the metal wire to the ground, preventing the build-up of excess charge. What did it say here? Yeah, it's also actually true. It doesn't really quite say this in the question, but it's also true that the aircraft and the fuel tanker are also connected to each other with what's called the bonding cable to ensure that no voltage can build up between the two. But by earthing the aircraft, bowser, and anything else, fuel tanker that is, then it ensures no charge can build up and no spark can jump. And that's question 4 complete.